Hello, everyone. Today's session is about unions and structures, and we are from CodingCubs. I'm Shashank, mentor of CodingCub, and today we're going to see about unions and structures. Okay, so let's first see all the data types we have in C language. Okay, today's C language session, and we're going to see all the data types present in the C language, and then we're going to start seeing why do we need structures and unions so that we can use it in our programs and everything. Okay, the first thing is, right, let's list out all the data types. The first data type, we there are mainly like 5 to 6 data types, like integer. Next, you get integer and a character, and you get what do you call and character, float, long end. All the data types that you have, normal data type that take about 4 bytes or 1 byte, in that way, in which only one piece of like a, either it's a number or it's a character, only one thing is taken inside. So if you want to take multiple things, what do? We use that we use what do you call we use called arrays, and these arrays are used to hold only homogeneous elements. Like if you want to take n number of let's start with the programming session itself directly. Let's I'll show you the tab right now. Yeah, can you see the GDP? I think you can see the GDP. Okay, so let's see. We have the integer type. We'll see all the data types right now again first. So integer like I, character C. Let's if we're having a array of characters in that way, so int of 10 is the array of character. Sorry, integers. Array of characters is called a string. So star of 10 equal to array of C. So let's see if we have a what do you call error in our program right now. Yeah, we do. Sorry. Okay. Int int is an array. Okay. Let's take int and character right now. Arrays are not coming. I think I forgot about it. Okay. So int and characters are there, and these are the normal data types here. Okay. These are the normal data types, and we use different data types like integer character, and we can print these also. We can assign characters integer to it. We can assign character like v and everything, and we can print them. We'll just try to print them here. I and C. Okay. So let's see it out now how we can. What's in? Oh, sorry. We it's like this, and now so now we have two characters over there. That is, sorry, we have two print statements. The two things are printed over there. That is the integer and the character. Okay. Now, let's see. Now, if we want different character, sorry, n number of integers in one, what are we gonna do is we're gonna do like 10. Okay. We can keep 10 away. Sorry, let's keep only 5. Huh. 5 over here, and then 1, comma 2, comma 3, comma 4, comma 5. These are the 5. And if you want like string is a group of characters. That means your name, your ID, your email, password, everything. Those are called as strings because you don't have space between them, and you don't take each and every character. You don't give each and every character at the same time. Okay. So this is 5. If you take 5 characters right over here, V K N M V K N M S. Okay. So the let's see now, are they going to print? No, because this is an array of characters and we're just printing one of them from there. And I will not specify. See, the warning is right over here. These are a number of argument expected as int, but there are two arguments like int star. Int star is actually a pointer. Okay. So array is actually definition of a pointer. Also, we can call it. So now what is it? We'll print different things. Like, for we have to use a for loop so that we have to print every character, every integer in the array. Okay. So let's see. I equal less than 5. Sorry, j less than 5. J plus plus. The next statement is printf percentile d I of j. This is gonna print different character, different integer types, integer array, different elements in the integer, and let's print the character also in the same way. But what we don't need the characters in different lines. We need the character in one line or like a string. So what we're gonna do here is printf, sorry, printf percentile s, because we are going to print a string. This percentile s takes in a string. Yeah. C. Okay. C and done. Now let's run this thing. Running. Oh, what's that? Exporter 5. Okay, sorry. This is forward. Done. We have one. Okay. We need to keep backslash n, and now we'll get all the integers in different line and the string in one line. So this is what the string does. It takes in the homogeneous characters and it's gonna give you the answer. Okay. Now, what if you need an array in such a way that it has to take an integer, a character, one integer and one character, or you need one variable in such a way that you can give it to a person that so that he can have a password and also a username. So whenever a variable is given to you, that variable contains both a password and a username, and it should also contain his phone number. Can we create in that way? That's where this structure and union gets in the picture. Okay. See, we can't. How much ever you try, if you write like int of I of 5, and you give like I, sorry, even if you try like j of 5, this contains another j of 5. Okay. This is a matrix with 2D array in such a way that it's going to contain even an array inside it. Okay, we can access each and everything. It's like a matrix. Okay, but we can't contain a different elements. That's where these structures come into place. Okay, now let's see what is a structure. Structure is nothing but it can contain. It's a type of array. Uh, type of array in such in a way that it can contain non-homogeneous in one variable. I'll just write the code and tell you how it works. Okay. Structure starts with the keyword struct. Struct. Okay. Struct. Okay. What does this struct do is it's going to ask for a variable. We'll give it a variable called st, and we're going to open the structure. This is how the structure is written. Inside it's called the body. Keyword, structure name, and the body. the body will contain different types of what you call uh, different types of data types. You can either write int of I and char of s, sorry, char of c, and the different we can also okay, this is the first thing we'll take in the structure. Okay, this is the first structure we have given, and always remember you have to have a semicolon after the structure definition. Okay, after the structure definition you should have that semicolon. Okay, now let's try defining it over here. Struct struct st and j. We are creating a structure st with a variable name a. Okay, sorry, not a, j. Ah. So what will remove all these things also. Okay, now structure j, variable j is given. Okay, now j has two values, I and c, both must be defined. Okay, j dot I equal to 10 and j dot j dot c equal to h. Okay, it takes in a character, so single quotes are required here. Let's give it a j itself. Okay, now printf percentile d, comma, j dot I. Let's print the character also. Now control C, j dot c. Okay, now let's see if there's an error. Has to be. No, see, we don't have any error right over here. So now we can see that there are two things that we can take in into a variable. So what do you call an array of structure? I mean, like in a one variable, you can have two data types in it. Okay, now let's use it like a what do you call a day-to-day problem. I'll keep it as a structure as called a user, and this is the phone number, and sorry, let's call it pin code, and area. The problem is here, we can't just take one character as an area. So we'll keep it at 10 digits. Okay. Now, now what let us do is, let's take this out. Now let's structure, we don't have st, we have the structure called user. And we'll give it the name. Let's see what we got. Hyderabad. Okay. And in Hyderabad, HYD dot pin code, we can give like 500074, and Hyderabad dot area equal to Hyderabad. I think wait, 5 6 7 8 9. Done. Okay. So these are 10 characters. That is the integer. Let's run it. I think it's gonna give me an error. Let's print these things. Uh, let's run it first. Character error. Hyderabad once. Okay, wait for a second. Let's give it character itself, HYD. Why are we wasting time? Let's keep it H. Okay. Now this is running. So the user Hyderabad, sorry, city, the same city. That's very different. Okay, city Hyderabad is given, pin code, area we have given. So let's print these things. So this is why we use it actually. The main thing is why we use it. Okay, Hyderabad area contains. Let's see, print the HYD dot pin code and print this. I'll see dot area. This is how we use it, and now see we have gotten 5000 and also H. Okay, so this is why structures are used. It's to get different types and multiple data types into one. Okay, now let's see about what you got. unions. Okay, I'll just share you one more thing. Yeah, let's just print out the size it is using. LD long and we're gonna see size of HYD. Okay, we're gonna see the size of the variable of or the structure we've created right now. The size of the structure is 8. Let me add this, sorry. Code equal to area equal to size, size equal to. Now this is how it's going to be done. And let's run it. Now see, the pin code is this, area is this, size is 8. Now how is it 8? How is it 8? Let's see the size of what you call, let's copy this. And we'll see the size of integer and the character also. Size of int, size of char, char, and we're gonna write here like, size of hyd dot I and size of hyd dot area. Sorry, pin code here. Pin code and this. What's going on? Size of int is 4. Size of character is 1. Okay. Long, we need to have 1 minute, right? Okay, now the size of character and this is 8. Okay, structure is 8. The size of integer is this much. Why did the size of the structure increase? Let's see by keeping the 74 right away. I think because we've given a humongous big integer, it's giving us that answer. Or else it's give us 5. 8. Okay, it might be taking like 4 plus 5 and giving the characters area also. Okay, that's right. Okay. Okay. See now what is happening? I don't even know. Okay. Now the pin code and area we have gotten right. The compiler just broke. The compiler cancel. Copy all this. Copy. I'll just reload the page. Sorry guys. Okay. Now let's paste the same code here. You know what happened? We've selected C. Stopping. Now this is the. Hmm. Okay, we'll wait for a second. This isn't going like well. Okay, 1 minute. I'll be back. 1 minute. Okay. So the compiler is now okay. Evidently, you. Okay, this is here and 1 minute. Stop sharing and start again. Online GDB. Okay. Uh, Okay, GDP is done. Now it's running the everything. Paste. Okay, now we've got it. Okay, guys, we're gonna continue right now. See, now the size is four, enters characters one, size is actually eight. Okay, why it is giving eight? I still don't know. Okay, but the thing is here, the size of each and every variable that we give into the structure is taken as individual sizes itself. So if you have integer four, character one, it is gonna take integer four and character one itself. Okay, there is not gonna be any change in that. And this is about structures. Okay, let's create a union also. What is the union and difference? Let's see one. Let's create like union and structure. The difference is main difference is that only one variable can be used in a union. Okay, even if you create n number of things, you'll use only one. It's like what you call a drop down box. You have paid or not. That is given in union in such a way that let's see receipt. Okay, paid. Paid. I've created a union, call it, and we've written what do you call it? Integer yes and integer no. Now integer yes and integer no are the two variables in the paid. Okay, or else we'll create another called like optional. Any like yes or no, or there's some error in it. So we are creating three. Now I'll just wait for it. Now here we have a structure. All this is about structure. Okay, now let's print. Yeah, so let's create a union like union paid p p dot yes equal to 1 and p dot no equal to 9 and so p dot let's what do you got p dot 1 equal to the 9. P dot uh, optional is equal to what do you get? Let's give n. Now let's print first just the first thing. What do you call just yes. Percentile d comma p dot yes and let's run it. Wait for a second. It's not value of yes equal to see the value of yes is equal to 78, but you've given is 1. How did it change? Let's see the value of then let's see the value of no right now. What's the value over there? Copy, paste. Value of no. Dot and no. Let's print no and see. Even the value of no is 78. How did we get the value of value 78? Okay, so the union takes in only one value. How many data types you give, it is going to take only the one value that you've given to it. Okay, the first value we have given to it is 1. So if we write a print statement over here, it is going to show us 1 also. See, the print value was 1, then it changed to 76. How did it change to 76? Now the value was 9 afterwards. The integer value was 9. Then afterwards, we have given the value n, and ASCII value of n is 78. So the ASCII value has been stored in the union P such that in a way that if we access the integer value of it, it's going to return the ASCII. If we ask for the character value for it, it's going to return the character. Okay, let me show you. No here, and let's print the value of character is C, and the value of an optional is n. This is how it is done. Okay. So this is the difference between union and structure. Okay. Now let's see the last thing. Last thing. Like instead of writing structure, Hyderabad city, Hyderabad each and every time like union paid, if you have to create another variable in after some time like that, you have to write like union and again paid. We can't remember all these things, right? So we can do another like small thing called type def. What does type def do is it is gonna give you the ability to change the name of the structure completely to one word. Okay, you're writing type def and write what you call the name over here. Like I want the name for this to be city. Okay, now take off this. Just keep the capital C so that we don't get any errors afterwards. Type def for union also. We'll keep only P and we'll keep right here P. Now, struct city is not required. We could just write city and union paid is not required. We can only write paid. Even here, struct city is not required. Oh, we didn't even see the sizes of it. Let's see about it right now. Okay. Now, what we have done is we have given a name for our structure called city. So we don't have to write every time structures in C, like variable name. Instead of this name, we're gonna write only this here. Okay. Let's see. I'm hoping we're not getting any errors. Yeah, we have no errors. See, now we can directly define the structure as city. Due to type def, we can create every single variable, like every single structure and everything, into one. Okay, into one name, and that name will be given everywhere. Each and everywhere you can give that name. We okay. This is what type def does. Okay, now let's 1 minute. I'll listen. The key points of structure we are going to see right now. Okay, 1 minute. Now, the key points of structures are like a structure. We can have multiple data types, multiple data types, and another thing is like the data each and everything. Data. So memory is assigned for each and everything, not data. Data is like what we give. Memory is the internal thing, whatever it's happening in a compiler. Yeah. Memory is allocated.
Shashank, the screen is not visible.
The screen is not available. Sorry. Thanks, Vijay. Yeah, sorry. Structure. The first thing is multiple. Sorry, I'm not good at this. Multiple data types. Memory is allocated for each variable or each data type for it. Each data type and each data type can has it have its own value. Its own value. Okay, these are the three things of the structure. Okay, now what are the unions? How is the union different? Let's see about it here. Uh, union. Now the first thing is here we can have multiple data types. Second thing is memory is allocated only for what do you call only for the largest data type present in the definition. Okay, like okay, once here. Okay, we have unions. Sorry, integer, and character. Integer is given four bits of memory, and character is given one. So The union's size is going to be 4. I'll just print out here size of this, sizes of this. Now print over here. What do we have? It's p, right? So p dot and yes, and here the p dot. Okay, and here we don't have to write again union of that everything. Union of p. We can just write union. Okay, sorry. We can just write paid. Yeah, I've run it. The size of integer is 4, the size of character is 1, and the size of union is 4 here. Why is it 4? Because the largest is 4 or 1. In 4 or 1, the largest is 4. So union takes in this, memory is allocated for only sorry allocated as the largest data type present in it. Yeah. So whichever is the largest data type present in it, that memory is allocated for the union. Okay. And the next thing, the third thing is only one value is used across the union. Okay. Sorry, union. So these are the differences here. Multiple data types are given for both. Okay. Memory is allocated for each data type in structure. Each data type has its own value in structure, and the memory is allocated for each and everything. Hmm. But in unions, only the memory is given for the union in such a way that it takes in the largest data type and it gives the memory in for the same thing. Huh. And the value is only one across the unions. Whichever variable you use, it's the same. Okay. So that is how it is given. And we've also learned about type def, right? Type def. Type def is just a keyword. That's it. What does it do is it's gonna give you like we can assign one variable like our own variable name for it so that we don't have to write structures and unions every single time like struct and let me write here the keyword also. The keyword is struct small. Here this keyword is union UI. Okay, these are the things. This is also small actually. 1 minute. Typed. Okay. Now we can use different things. We can assign. Sorry. Yes, assign variable name. Variable name for struct and union. Okay. This is what is happening. So these are the three things we have learned today. Do you have any? You guys have any doubts? These are the main things. These are just small parts of C programming. These structures and unions are going to be used in linked list, whichever we might tell you, like a linker list where these linker lists contain the address of the first and the last and the next coming array and everything. Structures are very important if you ask me. And real world, it's going to be very useful. Okay. Now, you guys have any doubts? I think you guys have any doubts? Yeah, I just thank you. Anyone any doubts? No doubts. Thank you. Okay. Okay. Anything from previous class sessions or anything in that way? Anything from previous sessions? Anything you can just type it down. Okay, I don't think anyone has anything. So, okay, for today, this is the thing, and structure, unions, and type def. These are the three things, and these are going to be useful in the future coming lectures and everything, and even for you exams and everything, for your exams and everything. Okay, do about it, and Tirupati. What is seven? Tirupati. Sorry. What's the difference between float and a double? Okay, integer, float, double. See, integer, float, and double. You have three things, right? Integer takes in the values from what do you call? Integer takes values from like some range, but all are like minus one to okay. But float and double are also there. Like what do you call? They are like same. All the three are same. Just that integer takes natural numbers. Float and double takes decimal numbers. Okay. Now float integer values take 1 minute. I'll just write it down. Okay. Int takes in natural numbers. Okay. Float and double takes what do you call? Okay, stop. So takes in decimal values. Even double takes in decimal values. Okay. So what is the difference between these three? This is the difference. Now between float and double, what is the difference is this can take values up to 32 bit. I mean, when 32-bit processor is used, float is going to be used. When there 64-bit processors are used, then a double value is used. That means float is given lesser memory space than double. That is the only difference. Okay. Did you guys? Okay. Did I answer your doubt? Shravan, did I answer your doubt? Or are you still confused? Hello. Did you get the answer? Shravan, is he online? Okay, then I think he went off. Okay. Did anybody get what did I just tell you about float, double, and one? So the thing is, integer takes in natural numbers and so till some values. Float takes in natural numbers and also decimal because decimal numbers contain all this. Screen is not clear. Okay, screen isn't clear. Can you see right now? What about now? If getting is the screen still not clear? I don't think it's okay. So like I just told you, natural numbers and decimal values. Decimal numbers or decimal numbers also contains natural numbers. So even a float can take natural numbers also. It's not a problem there. Even the double can take float values and integer values. It's like a set. So integer, float, double, they come in this way. Like 1 minute. If this is a double, then this is float. Oh, sorry. This is the double. Then this is float. A part of it is float, and in the float there's integer. So this is how the Venn diagram is going to be if you create it for three of this. So inside is an integer, then this is integer, this is float, and this is double. Yeah. So this is how it's going to be. The red color is the double, float, and the integer. Okay. Any other thing? Now it's clear, right? Just the size, memory size differs for three of each. See, if you need just value of 0 and 1, you don't go for in double and keep 1 and 0, because it's gonna have lot of empty spaces there. Okay, so that's why integer is given, float is given, double is given. Okay, I think anybody else has any doubts? Okay, then I think we can end the session. Okay, so these are the three things we have done today. Let's end the session over here. Now, the integers and all those things also. I'll just share this jam file with you guys, like a PPT or something like that. So yeah, so PDF in that way. Okay, and thank you. Still any doubts? I'm here for 5 more minutes. Thank you so much. Thanks a lot.